For this video, let's take a look at problem 15. X and Y are given to have a bivariate normal distribution with correlation coefficient rho equals 0. Prove that the X and Y are independent if and only if rho is equal to 0. Now, ordinarily, this is not an if and only if. This is only going to be true, well, I shouldn't say only, but for this problem, the fact that it's bivariate normal will be a very important assumption to make this an if and only if. To prove this, one direction is automatic. If X and Y are independent, whether it's bivariate normal or not, that automatically implies that the correlation coefficient is equal to 0. So that's automatic from class. So I have to worry about proving the other direction. So let's assume that rho is equal to 0. We're going to show that X and Y are independent. The way that we will show X and Y are independent is I will take a look at the joint PDF, and I will show that the joint PDF is equal to the product of the two marginals. Now, the joint PDF for a bivariate normal distribution is a long, painful mess, but let me start writing it out. So 1 over 2 pi, standard deviation for X, standard deviation of Y, square root of 1 minus rho squared, times e to the big mess here, negative 1 over 2 times 1 minus rho squared, times x minus its mean squared over standard deviation squared, plus y minus its mean squared over standard deviation squared, minus 2 times rho times x minus its mean, y minus its mean, over the product of the two standard deviations. Okay, now we use the very important fact that rho is equal to 0. If rho is equal to 0, 1 minus 0 is simply 1, so that goes away. If rho is equal to 0, then 2 times 0 times this, that goes away completely. Also, if rho is equal to 0, 1 minus rho squared is equal to 1. So this is times 1, so that goes away completely. And so this simplifies considerably as 1 over 2 pi, standard deviation for X, standard deviation for Y, times e to the minus x minus rho x squared over 2 sigma x squared. And I also have minus y minus the mean for y squared over 2 times the variance for y. Now this splits up. Let me write this as sigma x times the square root of 2 pi times e to the minus x minus mean of x squared over 2 times the standard deviation for x times 1 over sigma standard deviation for y, square root of 2 pi, e to the y minus its mean squared over 2 times the variance for y. And the 2 pi here splits up as square root of 2 pi times square root of 2 pi. So that's equal to the marginal density for a normal distribution with mean mu and standard deviation sigma x times the marginal PDF for a normal distribution with mean mu sub y and variance sigma y squared. So the joint PDF is equal to the product of the two marginals, and therefore x and y are independent.